Everyone has dreamt of time travel, but how much of that dream is reality? No film explores this question quite like Interstellar. A black hole appears near Saturn, following is chaos, destruction, and violent clashings of the planet's already fatally dangerous rings. A catastrophic happening that would devastate our solar system. But in Christopher Nolan's 2014 film Interstellar, things play out a little differently.
Everybody ready to say goodbye to our solar system? To our galaxy. Here we go.
In Interstellar, this black hole like structure is presented near Saturn, only not as a black hole, but as a wormhole. Now, before we get to the wormhole space time travel, we have to start smaller and earlier in the movie. The beginning of the movie is very important for the overall message of hope and wonder, and it also contrasts the rest of the runtime the most. Starting on their family farm, Matthew McConaughey's character Cooper, a former pilot, and his quiet but resilient family struggle to stay stable in a collapsing world, slowly falling away from science. Cooper continues to stress to his daughter Murph that hope and curiosity are what keeps them alive. The responsibility of science urges Cooper to follow his own words, as he is recruited to depart Earth on a mission to save humanity and find a new planet for life. Before he leaves, comforting Murph, he explains the risk of this job.
One for you. One for me. When I'm up there in hypersleep. Or traveling near the speed of light. Or near a black hole. Time's gonna change for me. And it's gonna run more slowly. Now, when we get back, we're gonna compare.
Time will run differently for us?
Yeah. Maybe by the time I get back, we might even be the same age. You and me. What? Imagine that. Ah, Murph.
You have no idea when you're coming back. No idea. Oh!
It is here that Cooper introduces the concept of time dilation using the twin paradox. As the movie progresses, time dilation is a major plot point, and the risk that Cooper took becomes reality, traveling time differently relative to his family and losing time. Time dilation is a concretely established idea in physics, first proposed by Albert Einstein. When an object travels close to the speed of light, or in a very influential gravitational field, time slows for the object relative to others. In everyday life, time dilation exists even for someone running instead of sitting, but at a scale so small it is entirely unrecognizable. The twin paradox from the scene is an imagined scenario in which two twins, one an astronaut that travels to space, end up with different ages when the astronaut returns home, as they experience time differently from the speed and gravity differences. But can this effect ever be so large that it feels like real time travel? A USC article called The Science of Time Travel by Mark Villanueva explores this question. Although the article is dated, the concept of time dilation is 100 years older and has still been validated. This concept, though, includes limits, such as the fact that objects with mass cannot reach the speed of light. As Villanueva states, as the faster they travel, the more energy is needed. But a large gravitational field may still allow for practical use of time dilation for future time travel. Most of the time travel seen in the movie is from the effect of gravity. The first destination of Cooper's crew, which includes the robot TARS, is Miller's planet, a planet that orbits the black hole Gargantua so closely that the gravitational effect of the black hole causes time dilation so massive that 1 hour there is equivalent to 7 hours on Earth. So how did Christopher Nolan propose this rate of time dilation? Well, the real answer is that he simply desired such a dramatic time difference. But that doesn't mean that it's not based in real physics. Kip Thorne is a Nobel Prize-winning physicist who currently works as a professor at Caltech and who has the scientific advisor for Interstellar. In a public lecture at the University of Minnesota, Kip Thorne went over his scientific contributions to the film, and at this lecture, he describes the time dilation of Miller's planet using calculations.
However, if Gargantua spins really, 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 really fast, then this ISCO, innermost stable circular orbit, is moved much closer to the horizon, and I just work out an approximate formula. 1 minus A is the standard formula in physics for the ratio of the angular momentum of the black hole to the maximum possible angular momentum the black hole can have. 1 minus A is 3 root 3 over 16 times the time dilation factor cubed. And he wanted a factor of 60,000 for that time dilation factor. That says that the spin of the black hole of Gargantua is within 1 part in 10 to the 14 of the maximum possible spin. That's astrophysically implausible, but it is physically possible.
So as we can see, although it's dramatized for the art, the extremity of the time dilation is theoretically possible. The consequences of it are seen in what I believe to be the heart of the movie, one of the most emotional scenes, in which time travel isn't depicted in the same way as in films like Back to the Future, but its devastating result of time dilation is in a tear-filled, one-of-a-kind acting performance, where Cooper, nearly the same age as when he departed Earth, receives messages from his children who are now unrecognizably older. So could this be you? Is it possible? Well, as noted by Kip Thorne, it's implausible, but not impossible. So the conclusion can be made with the established physics of time dilation and the equation worked through by Dr. Thorne, that it could theoretically happen to you. But in this case, it would probably be with a time travel of a few less years. Now that we've opened up the door for you to decide if you also want to break down light years away from home, away from your family, and covered relativistic time travel, we can now cover the kind that bends time completely. But we need a little bit of exposition. Before Miller's planet, which is millions of light years away from Earth, Cooper's team uses a wormhole near Saturn to travel through space and time. The reason I didn't talk about this before is because of a question asked in the film. How did the wormhole get there? This question is answered near the end of the movie, which I will now move to toward. Unfortunately, Miller's planet held no hope for life, and neither did the team's second destination, Dr. Mann's planet. On this planet, Dr. Mann, played by Matt Damon, is found and unintentionally sabotages Cooper's mission by damaging the ship when trying to flee his planet out of desperation. Although he failed, Dr. Mann still caused a detrimental loss to the mission in an attempt to make use of Gargantua's gravity to slingshot their way to the third planet in time. They realized that their ship was too heavy. As Cooper sacrificed himself to shed weight, he fell into the black hole and expected to die at contact, but instead he is transported to a higher dimensional space called a tesseract, where he is able to see Murph when she was a kid and interact with items on her bookshelves, a bridge between his time and hers. It is using this that he and Tars are able to send a message to Murph, the quantum data from in the black hole that she needs to solve the gravity equation I will introduce soon. The story gets complicated with the fact that this tesseract was delivered to Cooper and Tars by humans in the future, but specifically by Murph. The information Cooper gave her advanced humanity into a 5-dimensional species that put the wormhole by Saturn in the first place. So, Cooper traveled to the future with the help of a wormhole from future humans, communicated with Murph in the past, and was saved by Murph from the future of Cooper's present, or past Murph's future. But that's me complicating it. The bigger question isn't what's going on, it's how. Or simply, how could Cooper interact with his past world with no negative consequences? And how did future humans do the same to help Cooper twice? As brought up by Mark Villanueva from the USC article, one of the biggest problems with past time travel isn't just the physics of it, but the philosophical paradoxes, such as the grandfather paradox. The paradox explains the exact problem in the movie. If Cooper changes his past, wouldn't that change the future of his past, or his present, and possibly prevent him from even influencing his past? The answer is it could, but it doesn't necessarily have to. In the book Physics of the Impossible by acclaimed physicist Michio Kaku, he writes about many problems and potential solutions to time travel. One of the solutions he mentions is the many worlds interpretation. In this interpretation, Cooper doesn't change his past. He steps into a parallel universe and changes that timeline's past instead. So with this, we've solved backwards time travel, right? Well, there is another big issue around time travel that deals with wormhole travel, covered by Kip Thorne in his lecture. If a wormhole allowed for a bridge between space and time, particles or information would begin to loop through the entrance and the exit of the wormhole, eventually leading to a buildup or a repeat in these particles, and a buildup in energy which would explode. So could a wormhole even be stabilized? And how is it done in Interstellar? The short answer is that we can't know for sure yet, but many proposals have been made. If there could somehow be negative energy, this could stop an energy buildup by countering it. But we're not aware of how this could be done. In the film, Kip Thorne uses the fact that the future humans are capable of accessing higher dimensions and are much more advanced than us. But personally, this answer isn't sufficient for me, so luckily it can be specified and made more believable and accurate. First, it is imperative to understand that wormholes, being tunnels through space and time or through the three dimensions and time we interact with, are structures completely bound in our dimension. And in the case of Interstellar, the wormhole is of three dimensions. It is completely reasonable that a species of higher dimensions would have an easier time making a structure of a lower dimension, just like how it's easier for humans to cut out a square of paper, then add 5 more sides to make a cube. Or, I don't know why I said that, why it's easier for us to draw a square and not draw a cube. We can't technically draw a cube on a paper that has one side. I mentioned earlier that Cooper and Tars informed Murph of the quantum data from the black hole that she needed to advance humanity. This quantum gravity data is more than merely buzzwords. Quantum gravity is actually one of, if not the largest unknowns in modern-day physics, and it's absolutely essential in progressing our knowledge of the universe. The problem is that gravity is a force that we have not fully connected to the world of quantum physics, and being able to do so would certainly advance science, especially physics, regarding gravitational beasts like black holes and wormholes. What this means is that the answer to time travel may not be here right now, but we know of a few places it could lie, such as the quantum gravity. In this way, the film's choice of using quantum gravity information as the key to advancing humans is perfectly in line with what physicists today believe may be the answer. Near the end of his lecture, Kip Thorne addressed that he is doubtful of this possibility to harness a wormhole, let alone create one. However, being the scientific advisor, it's more important to note that although he allowed for room for creative freedom, the science in the movie, even the complex wormhole and higher dimensions, is all grounded in genuine theoretical physics. He went on to claim that he has been wrong before and is fully aware of its possibility, even if doubtful. On the other hand, Michio Kaku and his many presented solutions share an optimistic viewpoint for time travel, just as Christopher Nolan and his ambitious ideas do as well. So while skepticism is important, especially in a field like science, next time you watch Interstellar, take a step back and acknowledge the fact that nothing you're watching is impossible, and in fact, it's quite possible. The movie stresses to have hope on a dying planet and faith in the people you love. Even with its immensely emotional and groundbreaking contents, the message is still clear. Don't let go of ambition and keep curiosity at all times. I think of a quote from Cooper in the movie where he says, "We've always defined ourselves by the ability to overcome the impossible, and we count these moments These moments when we dare to aim higher, to break barriers, to reach for the stars, to make the unknown known.